Picture this. The world as you know it has changed. The lights are out. The hum of electricity that once powered everything from your refrigerator to the local hospital is gone. You're standing in front of an abandoned power substation, and you realize that the knowledge to bring it back to life could mean the difference between survival and chaos. But here's the thing. Most people have no idea where to even begin. Today, I'm going to walk you through exactly how to restart an abandoned power grid step by step. This isn't just theoretical knowledge. This is survival information that could save lives, including your own. Welcome back to the channel. If you're new here, we focus on practical survival skills that go beyond the basics. Today's topic is one of the most requested and, honestly, one of the most critical skills you could ever learn: how to safely restart an abandoned power grid. Now, I know what you're thinking. This sounds incredibly dangerous, and you're right, it is. But with the right knowledge, the right precautions, and a clear understanding of what you're dealing with, it's absolutely possible. Why would you ever need this skill? Well, in a long-term disaster scenario, whether it's an EMP attack, a societal collapse, or a natural disaster that's knocked out infrastructure for months, abandoned power facilities might be your best chance at restoring electricity to a community. Hospitals need power. Water treatment facilities need power. Communication systems need power. If you can bring even a small grid back online, you become invaluable. Before we dive into the technical steps, I want to mention something for those of you who are really serious about this survival journey. We've put together a collection of resources that complement what we talk about on this channel. If you check the link in the description, you'll find our Gamma Roach ebook. It's a comic book that explores survival themes in a post-apocalyptic world where adaptability and knowledge are everything. It's a great companion piece to the practical skills we cover here, and honestly, it's just a fun way to think about these scenarios from a different angle. Also, if you're enjoying this content and want to rep the survival mindset, we've got some merch available. 2 links in the description. It's a way to support the channel and show that you're part of this community that values preparedness. All right, let's get into it. I'm going to break this down into manageable steps, warn you about the most common mistakes people make, and give you the critical safety information you need to know. This is going to be detailed, so grab a notebook if you want to take notes. Before you touch a single switch or wire, you need to understand the beast you're trying to wake up. A power grid, even a small local one, is a complex system with multiple components: generators, transformers, circuit breakers, control systems, and miles of transmission lines. When a grid goes down and stays down for an extended period, several things happen that make restarting it dangerous. First, equipment deteriorates. Moisture gets into electrical components. Rodents chew through insulation. Corrosion sets in. What might have been a perfectly safe system 6 months ago could now be a death trap. Second, you're dealing with what's called a black start situation. This is when a power station needs to be restarted without relying on the external electric power transmission network. Normally, power plants use electricity from the grid to power their own startup systems. Without that, you're essentially trying to jumpstart a massive electrical system from scratch. Third, and this is critical, you could be working with voltages that will kill you instantly. We're not talking about the 120 volts in your home. Transmission lines can carry hundreds of thousands of volts. One mistake, one moment of carelessness, and it's over. So here's your first and most important rule. Never attempt this alone, and never attempt this without proper protective equipment and training. What I'm teaching you today is knowledge for emergency scenarios, where professional help isn't available and lives are on the line. Your first step is assessing whether the facility is even salvageable and safe to enter. Approach the site during daylight hours. Look for obvious hazards: downed power lines, structural damage to buildings, signs of fire or explosion, flooding, or hazardous material spills. If the facility has been abandoned for months or years, assume wildlife has moved in. I'm not just talking about mice depending on your location. You could be dealing with snakes, raccoons, or even larger animals that have made transformers and control rooms their home. You need proper personal protective equipment. At minimum, you need insulated gloves rated for high voltage work, a hard hat, safety glasses, steel-toed boots with electrical hazard protection, and flame-resistant clothing. You also need a multimeter, a voltage detector, lockout-tagout devices, and ideally, a Faraday suit if you're going to be working near high voltage equipment. Bring a partner, someone who stays at a safe distance and knows to call for help or pull you out if something goes wrong. In electrical work, we call this the buddy system, and it's saved countless lives. Document everything, take photos, make notes. You want a clear record of what the facility looked like when you arrived. This isn't just for safety, it's for the restart process. You need to understand what you're working with. Once you've determined the site is physically safe to enter, your next job is securing it and performing a detailed inspection. This is where patience is critical. Rushing this phase is the #1 mistake people make. Start by ensuring all main circuit breakers are in the off position. Every single one. You're creating a safe baseline where nothing should be energized. Use lock-out, tag-out procedures. These are locks and tags that physically prevent switches from being turned on accidentally. Even if you're alone, lock them out. Treat every piece of equipment as if it's live until you've personally verified it's not. Now, begin your inspection. You're looking for several specific things. Check all visible wiring for damaged fraying, exposed copper, burn marks, or corrosion. Inspect transformers for oil leaks or signs of overheating. Look inside control panels for signs of moisture, rust, or pest damage. I check the foundation, and mounting of major equipment vibration and shifting can loosen critical connections. Pay special attention to the generator itself. If this facility has a diesel generator, check the fuel system. Old diesel fuel goes bad dit, becomes thick, forms sludge, and can clog fuel lines and injectors. If the fuel is more than a year old, it's probably unusable. You'll need to drain it and find fresh fuel, which, in a survival scenario, is its own challenge. Inspect coolant systems. Generators need cooling to operate, and if coolant has leaked out or become contaminated, the generator will overheat and fail within minutes of starting. Check battery systems. Most facilities have large battery banks that provide backup power to control systems. After months of disuse, these batteries are likely dead or severely degraded. You may need to bypass battery systems or find alternative power sources for the control systems. Here's a scenario to illustrate why this matters. Imagine you skip the inspection phase and just try to power everything up. You flip switches, and, unknown to you, there's a short circuit in a control panel caused by mouse damage. The moment power flows, that short circuit causes a fire. Now you're dealing with an electrical fire in a facility full of flammable materials and high-voltage equipment. This is how people die. Don't skip the inspection. Now that you've completed your inspection and identified problem areas, it's time to test individual circuits. This is methodical, slow work, but it's absolutely necessary. Using your multimeter test for continuity in circuits, you're checking whether electrical pathways are intact and whether there are any unintended connections that could cause shorts. Test insulation resistance. This tells you whether insulation on wires has broken down and whether current might leak where it shouldn't. This is also when you isolate damaged sections. If a particular circuit or piece of equipment is compromised, you need to physically disconnect it from the system. Remove fuses, disconnect wires, whatever it takes to ensure that damaged equipment can't interfere with the restart process. Create a map of what's working and what's not. In a real power facility, there would be detailed schematics, but in an abandoned site, those might be missing or outdated. Your hand-drawn map might be the only guide you have. One critical thing to understand: you don't need the entire grid functional to provide power. In a survival scenario, you're probably looking to energize a small section, maybe enough to power a few buildings or a water pump. You can often isolate a portion of the grid and bring just that section online while leaving damaged areas disconnected. Here's where things get real. You're going to attempt to start the generator without any external power. This is the black start I mentioned earlier. First, ensure the generator is mechanically sound. If it's a diesel generator, check the oil level and condition. Old oil needs to be drained and replaced. Check air filters. They may be clogged with dust or debris. Inspect the starter motor and starting battery if the generator has an electric start. More likely, in an emergency scenario, you'll need to hand crank the generator if it has that capability, or use a separate small generator to power the starting system. For diesel generators, you'll need to prime the fuel system. This means manually pumping fuel through the lines to remove air bubbles. Air in a diesel fuel system will prevent the engine from starting. This can take sometimes 30 minutes or more of manual pumping. Check the cooling system. Fill the radiator with coolant. If it's low, make sure the water pump belt is intact and properly tempered. Now, here's something most people don't think about. The governor system. Generators need to run at a specific speed to produce the correct frequency of electricity in the US. That's 60 Hz, which requires a precise engine speed. The governor controls this. If the governor system is damaged or misadjusted, your generator might run, but it won't produce usable power. Adjusting a governor is complex and requires mechanical knowledge, but at minimum, make sure all linkages are connected and moving freely. You're ready to attempt the start. This is a tense moment. Before you pull the starter cord or engage the electric starter, do one final safety check. Is everyone clear of moving parts? Are all your tools and materials away from the generator? Is the main circuit breaker still open so the generator isn't trying to power the entire grid on startup? Okay, start the generator. If it's been sitting for months, it might not start on the first try. Be patient, keep trying. Listen to how it sounds. A healthy diesel generator has a specific rhythm. Irregular firing, excessive smoke, or unusual noises are warning signs. Once it's running, let it warm up. Don't immediately load it with electrical demand. Let it run at low or no load for at least 10 to 15 minutes. This allows oil to circulate components to reach operating temperature and gives you time to watch for problems like leaks, overheating, or mechanical issues. Monitor the voltage output. Your generator should be producing voltage close to its rated output, typically around 480 volts for industrial generators or 240 volts for smaller systems. If voltage is wildly incorrect, there's a problem with the generator's voltage regulator, and you'll need to troubleshoot that before proceeding. Now, gradually introduce load. Don't flip the main breaker and try to power everything at once. Instead, close breakers one at a time, starting with the smallest loads. Maybe start with just the lighting circuits in the control room. Watch how the generator responds. Voltage should remain stable, and the engine sound should be steady. Gradually increase load, add more circuits, watch for voltage drops, which indicate the generator is struggling, or frequency changes, which mean the governor isn't maintaining proper engine speed. Here's a scenario. You start the generator, and everything seems fine. You get excited and close the main breaker, trying to energize several large motors at once. The inrush current, the initial surge when motors start, is massive. Your generator can't handle it. The engine bogs down, voltage collapses, and the generator stalls out. Now, you have to start over, but worse, you may have damaged the generator or blown circuit breakers throughout the system. Always add load gradually. Assuming your generator is running smoothly under test loads, you can now consider energizing a section of the grid. This is where your earlier work isolating damaged circuits pays off. Start with the section closest to the generator. Close breakers methodically, moving outward. With each breaker you close, you're asking the generator to power more transmission lines and more load. Watch for problems. If a breaker trips immediately when you close it, there's a short circuit somewhere in that section. Don't keep trying to close it. That's a sign of a serious problem that needs investigation. Listen to the generator. Any change in sound indicates a change in load. Voltage and frequency should remain stable. If they start to fluctuate wildly, you're either overloading the generator or there's a fault somewhere in the grid. In a survival scenario, you need to prioritize loads. What absolutely must have power: water pumps, medical equipment, refrigeration for food and medicine, communication equipment. You can't power everything, so decide what matters most and ensure those systems are on dedicated circuits you can control. Implement load shedding if necessary. This means intentionally disconnecting less critical loads to keep the generator from being overwhelmed. It's better to provide stable power to critical systems than to try powering everything and have the whole system crash. Congratulations, you've got a section of the grid energized, but your work isn't done. Now, you need to keep it running. Generators require constant monitoring. Check oil levels and temperature regularly every few hours at minimum. Monitor coolant temperature. Watch for leaks of fuel, oil, or coolant. Listen for changes in engine sound that might indicate developing problems. Keep detailed logs, record voltage, frequency, oil pressure, coolant temperature, and any unusual events. This documentation helps you spot trends that might indicate problems before they become critical. Fuel management becomes crucial. Diesel generators consume fuel quickly. A large generator might use several gallons per hour. In a survival scenario, fuel is precious. You need to calculate how long your fuel supply will last and ration electricity accordingly. Maybe the grid only runs certain hours of the day. Maybe you alternate which areas have power to conserve fuel. Watch the weather. Lightning storms pose a serious threat to a newly energized grid. If severe weather is approaching, you may need to shut down the grid to prevent damage from lightning strikes or line damage from falling trees. Let me tell you about mistakes that have killed people or destroyed equipment so you can avoid them. Mistake 1. Assuming equipment is dead. Always test with a voltage detector before touching anything. Assume it's live until proven otherwise should be your mantra. Capacitors can store lethal charges for hours or even days after power is removed. Mistake 2. Working alone. Electrical accidents happen fast. If you're alone and something goes wrong, there's no one to help you. Always have a partner keeping watch. Mistake 3. Ignoring environmental hazards. Wet conditions make electricity exponentially more dangerous. Never work on energized equipment in the rain or in damp conditions unless absolutely necessary. And, if you must, take extreme precautions. Mistake for overloading the generator. It's tempting to want to power everything, but an overloaded generator will fail, possibly catastrophically. It's better to power a few critical systems reliably than to try powering everything and end up with nothing. Mistake 5. Neglecting maintenance. Once you've got the system running, it's easy to get complacent, but generators need constant attention. Skipping oil changes, ignoring small leaks, or failing to monitor temperature can turn a functioning system into a dangerous failure waiting to happen. Here's something critical. Sometimes the right decision is to not restart a power grid. If the facility is too damaged, if you don't have the resources to do it safely, or if the risks outweigh the benefits, walking away is the smart choice. Signs that you should abandon the attempt: extensive water damage, evidence of fire damage to critical components, missing major components like transformers or circuit breakers, structural instability in buildings, or hazardous material contamination. There's no shame in recognizing that a job is beyond your capabilities or resources. In a survival scenario, staying alive is more important than having electricity. There are alternative power solutions: solar panels, wind turbines, smaller, portable generators that might be safer and more practical for your situation. Restarting an abandoned power grid is one of the most challenging and dangerous tasks you could undertake in a survival scenario. But it's also one of the most impactful. The ability to restore electricity to even a small area can mean the difference between a community surviving and thriving, or descending into chaos. Everything I've taught you today is information I hope you never need to use. But if the day comes when you're standing in front of that abandoned substation and you realize you're the only one who knows what to do, this knowledge could save lives. Remember, safety first, always. Methodical, patient work over rushed actions. Test everything, assume nothing, and never work alone. I want to hear from you. Have you ever worked with electrical systems? Do you have experience with generators or power grids? Drop your thoughts and experiences in the comments below. If you found this video valuable, please hit that like button. Helps the algorithm show this content to more people who need this knowledge. And if you're serious about survival preparedness, subscribe to the channel. We're building a community of people who believe in being ready for whatever comes. Stay safe out there, stay prepared. And remember, knowledge is the ultimate survival tool. I'll see you in the next video.